Well, in this week, we are going to spend most of our time on practicing signal processing. And to do that, I have a software MATLAB. This MATLAB is very popular amongst students in the institutes and the universities, and we are going to use MATLAB for certain basic signal processing. And we will see that in the future students or practitioners use certain softwares which are already developed for doing the signal analysis. And of course, I had told you during the data acquisition that there are some commercial software like LabVIEW etc., which are used for data acquisition and control of the hardware devices. But now in MATLAB, what we have, when we have the numbers already acquired and stored in the memory of a computer, how we can do certain analysis. Excel, Microsoft Excel is one another example, wherein we work on the stored data. But in this class, I am going to introduce you to MATLAB, where every number is actually treated as a matrix. And so basically, this is all matrix manipulation, and even suppose I have one character, this is 1 by 1, this is number of rows and this is number of columns. So certain rows and columns are to be used, and then I can have matrix of many rows and columns and so on, and I can treat these numbers accordingly. Now, to invoke MATLAB, what we do is, if I come here to the software wherein I have already opened up MATLAB, you will see few windows, and actually we will be working on this command window, wherein we will be doing some. For example, once MATLAB is there, you can type certain commands like computer. This means this is an Windows 64-bit system, PC Windows 64. So commands like date, 21 December 2017 is today's date. I could do a quit and then I can come out. I will not do quit right now, and so on. So for example, if I give a variable a is equal to 10, okay, it means that a is equal to 10. So if I go to the memory of the MATLAB, I can see, do a command whose, and you see a is a 1 by 1 matrix which requires 8 bytes of data, and then a double class and so on. So because this is a 64-bit machine, okay, each data requires 8 bytes and so on, because 8 times 8 is 64. Okay. So I can clear everything in the memory. So clear all, and if I do a who, it shows nothing. If I do a whose, it shows nothing. Now again, if I type a is equal to 10, and then do a who, it will tell me that the variable currently stored in the memory of the system is a. It does not tell me anything regarding the dimensions. If I do a whose, it will tell me that it is a 1 by 1 matrix. So similarly, I can store up different values. So b is equal to 10 or 20. Okay. So if I do c is equal to a plus b, it just adds up and does a 30. Now there is always a command I am giving b is equal to say 20. If I put a semicolon, it will not prompt me the value of b, and then this 20 is already stored into the variable name b. But if I b is equal to 20 and do not give any semicolon, it will prompt me the value of b. So it is up to an user how you want to do it. So we just saw how easily two numbers are added up, where c is equal to a plus b. I can say D is equal to C. So then if I do a whose, I should be getting A, B, C, D. Is that A, B, C, D? If I want to know the value of A is 10, B is 20, C is 30, D is equal to C 30, and I can clear everything from the memory. Clear all, do whose, so nothing is there. So always a good practice to clear everything in the memory once you do a fresh set of computation. Okay. Now let me show you some of the things. If I want to treat a number as a complex number, I can say I have cleared everything. So I will give a fresh number. A is equal to complex 1, 2. Sorry, I can always do a help complex. Okay, so C is equal to A plus complex A plus B. So I can write C is equal to complex 1, 2. So you see, the C is a complex number with a real part A, real part being equal to 1 and imaginary part equal to 2. I could write D is equal to 3 plus 4I. So this is a complex number. So very easily I can write down the complex numbers. So I can, if I want to find the magnitude of the complex number, I can do absolute D. So it is 5. It is the magnitude of this complex number. If any time I have a problem in MATLAB, I can do help and that command. So for example, I did right now help complex, and then you can see A plus BI, and then I can get the imaginary real parts. For example, C is equal to 5 minus 4I. It's a complex number. I can say what is the imaginary value. Imag C is minus 4. Real C is 5. So thus I can give variables as real numbers, as complex numbers, as the case may be, and I can do any sort of math operations. All the arithmetic operations can be done. Now coming to matrix multiplication, suppose I have a matrix A is equal to second bracket 1, 2, 3, and I give a colon 4, 5, 6, then 7, 8, 9. So this is basically a 3 by 3 matrix. So I have written the first column, first row 1, 2, 3 with a semicolon. Then I have the second row 4, 5, 6, and then the third row 7, 8, 9. So this is a 3 by 3 matrix. So I can go do a whose, and you see A is a 3 by 3 array of a number. So matrix A is a 3 by 3. So I can give B is equal to, so if I want to multiply a 2 matrix, C is equal to matrix A times matrix B. So this is M times N. So this is maybe N times 1. So C will be M times 1. So we have already defined, just let me clear it again. Sorry, clear all. It's fresh. So my matrix A is a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, and B is a matrix. This is 3 by 3. This is 2, 5, 6. I will do a, this is 1 by 3. Okay. So, this will not allow, if I do a matrix multiplication, let me first write A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, B is equal to 2, 5, 6. So, B is a 1 row and 3 columns. So, this multiplication like C is equal to A times B will not be correct, because I have to make it B transpose. So, let me give a B, or maybe BB is equal to B transpose. So, in matrix multiplication, so transpose of a matrix is given by the command, say B, this sign here. So, I have got BB as B transpose. So, now I can multiply C is equal to A dot BB. Sorry, I have to give the command C is equal to A star BB, right. You see that? This multiplied C is equal to A times B transpose, where this was 3 by 3, this is 3 by 1. So, this will be a 3 by 1. So, now these numbers were real numbers, they could have been complex numbers as well, and so on. Now, I can generate, so let me clear everything. Okay. Now, see, if you look in the internet, and there are many resources for understanding MATLAB and learning MATLAB. But the way I am going to tell you is certain key elements in MATLAB which are going to help us at least generate certain signals, plot them, and then do certain arithmetic operations. So, all the arithmetic operations of addition, subtraction, multiplication, divisions can also be done, multiplying with a constant, handling complex numbers, finding out certain parameters of this number, of array of numbers, like mean of an vector of numbers, and so on. I want to generate a time sequence T is equal to 1 colon 1 colon 100. So, this means it is generating a series of number, a row vector, okay, with 100 columns, where all elements starts from 1, it increments by 1 and goes up to 100. So, 1, 2, 3, 4, and so on. If I plot T, it is 1, 2, 3, 4, 5, all the way up to 100. So, this is what my T is. Okay. This sometimes helps us in indexes, etc., when we want to help. Of course, I can use the arithmetic functions like a help sign. So, it does the sign of the element of argument is in radians. Okay. We also have sin d, etc. So, help cosine. So, I can hand in trigonometric functions also, help exponential. Okay. It does an exponential operation. Okay. So, I can do many complex operations, trigonometric expressions, logarithmic expressions, and so on. Okay. Now, let me show you if I want to multiply or let me find out the mean of an array of numbers. So, I can do a help mean. So, average value mean is the mean value of the elements in X if X is a vector. Okay. So, you can do median, standard deviations, minimum, maximum variance, covariance and so on. All this is possible in this operations. I can find out the eigenvalue of a vector also. For example, a 3 by 3 matrix. So, for example, help SVD is one command. It gives the singular value where S is contains the singular value. Okay. I can do an eigenvalue also, help EIG. Produces the column vector E containing the eigenvalues of a square matrix A. So, let me give you a square matrix clear. A is equal to I can do eigen A. It is giving the eigenvalues of this matrix, square matrix A, right. But many times if I go back to my example, so B is equal to 1, 2, 3. If I try to multiply C is equal to A times B, it will give me an error because I am trying to multiply a 3 by 3 matrix with an 1 by 3. Okay, it will give me an error right now. So, inner matrix dimensions must agree as is the. So, that is why if you have to take V transpose, it will work. C is equal to A star B transpose. Okay. So, because now the B transpose looks like this, and there is no end to how much I can change and so on. Now, let me generate two strings of vectors. So, T is equal to 1 colon 1 colon 100, and let me generate Y is equal to 20 to 20 or 20 to 5. Okay, let me generate Y, same thing. If I plot, I could do a help plot. So, there are many commands and options of plots. Plot x y, plots the vector y versus vector x, okay, and so on. And then you can give certain commands, etc. For example, plot x y C plus gives the C undotted line with a plus at each point and so on. So, now I will plot T y. I should get a straight line at 45 degrees. See this? This is my T, this is my y, and I have plotted it. Okay. So, this is very simple plot functions. I can close it. Of course, if you go to MATLAB, you can do that. And another thing in MATLAB is I can save. So, I can do math operations. I can do with complex numbers. I can do matrix manipulations like transpose, inverse, etc. I can find out eigenvalues. I can plot. Now, another very important thing is I can load data from file. I can store or save data to a file. So, you see, typically when I have a data acquisition device or a recorder. I can have all these files in a file format. So, MATLAB very easily I can take text files, take dat files, I can take files out of Excel. So, these are some of the common data formats. Okay. And these data can be stored, can be recovered, and then I can store a load from a file name. For example, if I come here, if I do load, the best part about MATLAB is that you have any problem with anything, just do an help, and I find that very convenient myself to. Okay. So, you can load a file. You can give the file name, you can give the variables. So, variables can be stored a mat type, certain ASCII type. Okay, it will take it as an ASCII file and so on. So, I can load certain text files and so on. Right. Similarly, help save. Save file name stores all variable into a workspace. Okay. I can add so on. And what format you want to save. Okay. And of course, like in any software with different versions, there are updates and so on. And I here do not recommend any particular version of the software. So, whichever is available at your convenience or at your place, you can use it for doing certain analysis. The reason I wanted to show you this is, we will be using this subsequently for doing certain signal processing in the next classes. But now, let me give you some other examples as to this can be used also to do FFT. And let me plot a sine wave, for example. Let me generate the time series. Now, let me generate x or y is equal to 10.0 star sine 2.0 star pi. MATLAB understands pi as okay, 22/7, 3.141. So, I will give the frequency of the signal 2 pi f t. So, f may be 10 hertz star, t means at whatever time. So, maybe every 0.001 seconds, 0.001 seconds, and star t. Okay. So, out of generate a sine wave, let me plot t versus y. You see, I generated one sine wave. Okay. Some takeaways from here is, you can always in MATLAB for debugging, you can always go back to your arrow key and it will get back your previous command. So, I have generated this y is equal to 10.0 star sine 2.0 star pi star 10.0 star 0.001 star t. See, my t was always 1. So, I have 100 data points, and this is the frequency of the signal. Okay. So, it is that, and what is the time period? So, time period is t is 1 by f 1 by 10, this is 0.1 seconds. You see here my maximum value of t is 100. So, if at t is equal to 1, this is 0.01, and t is equal to 100, this comes to 0.1. So, that means I am having only one wave, and this is 0.1 second. Okay. And this is my 10. See that? So, now if I want to make 10 waves, all I do is then I will, or if I increase the frequency, I will make it 100 hertz. I can plot I will you see that I have got 10 waveforms. Of course, I will come to this later on because my resolution was not that fine. So, that is why this clipping occurs, but nevertheless, once I went to 100, my signal become okay. I can go back to my original and make it back to 10, and I can again plot t and y. I got back my original sine signal. So, in this brief exercise on MATLAB, I just told you some of the elementary commands as to how we can treat numbers, find out, treat them as real numbers, complex numbers, do certain matrix operations, and do addition, multiplication, subtraction, etc., and then plot files or plot expressions, and then save values and so on. Okay. So, some of these examples you will see in my book in the appendix, okay, which we will be discussing in the subsequent classes. Thank you.